So let's now talk just a little bit about how to find skew asymptotes. So by definition, f of x has y equals to kx plus m, so this is a skew line, as a skew asymptote or oblique asymptote as x goes to, well, plus infinity, if the limit as x goes to plus infinity of the difference in height between these guys, and I don't really care about the signs. I could do absolute values here, but it doesn't really play a role. If I put minus infinity here, I have to put minus infinity here. In the lecture notes, I give a method. So the method is as follows. So it's a two-step method. So f of x has y equals to kx plus m as skew asymptote. And in fact, this is a really good method because it's if and only if. So this method always gives you the correct answer. And it's in two steps, like this. Now this is a two-step method where you have to do step 1 first and then step 2. This is because in step 1 you identify your k, because you don't know your k and your m at first. So you do this first step where you compute f of x divided by x. If you get a number here, that's your k, and then you can use that k in your second step, and then you'll get your m. And here we can note if either the limit in 1 or 2 do not exist, f has no skew asymptote. So in some methods, if parts of the method break down, it just means that the method is bad. Here, if it breaks down, it means that there is no skew asymptote. So this is a good method. So let's look at an example where we find the skew asymptote both using and not using this method. So let's put f of x equals to some rational function like this. And now the question is, does this guy have any skew asymptotes? What you can do first is you can do a polynomial division. And I won't do it explicitly to save time. But if you do it, you'll get 2x plus 5 minus x plus 4 divided by x squared plus 1 like this. And notice now, what does this tell us? Well, this tells us that if we do lim x tends towards infinity of f of x minus 2x plus 5, this is the same as lim x tends to infinity of minus x plus 4 x squared plus 1, right? Because if I take this guy minus this guy, this is what's left. And here, of course, I have an x who's the strongest guy on top. I have an x squared who's the strongest guy below. X squared kills the x, so the limit here is 0. So this means f has y equals to 2x plus 5 as skew asymptote, as x tends to plus infinity. So this is an example where we don't need the above method. But what if we want to use the above method? And there are functions where it's really unclear if they have skew asymptotes from their expressions where we need this thing. For instance, an example you should do is y is equal to x, e to the 1 over x. So this guy, it turns out, has skew asymptote this, and that's not at all obvious from the expression unless you know how to Taylor expand. Then it's kind of obvious. Anyway, you should try to apply the method to this guy and see if you get that guy or something similar. Anyway, let's now apply the method to this guy here. So in order to keep the method in plain view, let's just delete this stuff. And then let's do step 1. So now we have no idea what the skew asymptote is. And all I do is I compute the limit as x goes to infinity of f of x divided by x. So by plugging in, we get 2x to the third plus 5x squared plus x plus 1 divided by x squared plus 1. And who are strongest now? Well, downstairs we have x to the third, and upstairs we have x to the third. So factoring out, what do we get? Well, we get x to the third and x to the third. And upstairs we get 2 plus a lot of things that will tend to 0. And downstairs we get 1 plus 1 over x squared that will tend to 0. So all in all, this will give us 2. So now this is the value for k. Doesn't tell us that we have a skew asymptote yet. We need to find the m as well. So how do we do this? Lim x tends toward infinity, and then we do f of x minus kx, which in this case was 2. So this is lim x tends towards infinity of minus 2x. Okay. Now I have to play a little bit around with algebra here. I need to put everything on a common denominator. Let's see if I have the room. So 2x to the third plus 5x squared plus x plus 1 minus, and I multiply him with him, 2x to the third minus 2, all of this over this, and then I continue. And what happens? Well, this goes against this, and these two guys give us a minus 1, so I have here 5x to the square plus x minus 1 divided by x squared plus 1. And now who's the strongest guy here? Well, that's x squared. Who's the strongest guy here? X squared. I factor them out. What do I get? X squared divided by x squared. Here I get 5 and a bunch of terms that will go to 0. Well, let's write them out like this. And then I get here 1 plus 1 over x squared. Well, this kills this, and it's just the 5 left. So this tells me that y is equal to 2x plus 5 is the skew asymptote of this guy, which matches exactly what we found by doing polynomial division here. And we're done. So I leave it as an exercise in this course to prove that if this method works, then this is the skew asymptote, and to prove that if this is the skew asymptote, then this method works. And this you have to do by combining this information here with this definition here. So it's actually quite a friendly little exercise.